I'm Sai Prasad Bhagatrao Lendale, fourth year BTech student. And today's my topic is Transformer Architecture for ISC 2 in Deep Learning subject. Okay. Hey, here is the introduction part of Transformer Architecture. Transformers are the deep learning architecture mainly used for sequential data such as text, speech, and time series. It is used like a text data. Okay. Then replace the recurrence, RNN, and LSTMs. The attention mechanism to capture relationship between the elements in sequences. It is replaces like old RNN and LSTMs are replaceable by this transformer architecture. Okay, the architecture process data in parallel, improving training and speed and efficiency. The introduced by this transformer architecture in 2017 by the Vaishnavi 8 in the paper. The attention is all you need. Concept description of transformer architecture. Here, what is the transformers? Are the deep learning models that used in attention instead of recurrence. They processes all tokens in parallel, capturing long range of dependencies. Here, he can capture long range of dependencies in transformer architecture. Used for text, vision, and speech. Tasks are tasks with highly accuracy and stability. Here are the some key points of transformer architecture. Self-attention. Self-attention means learns relationship between tokens. Personal encoding means maintain sequence order. And here is the last one, not a feed forward network, means refines and transform the token features. Hey, here is a working mechanism of transformer architecture. The attention, the process, context, understanding. The transformer works by calculating attention squares between the every pair of tokens in the sequence to the understand contextual data in relationships. Okay. This process model using the self-attention function which can be determines much focus each word should be given to the others in the input layer. It can be formulated as a attention is equal to in bracket q k v is equal to softmax function in bracket q into upper power of t and in bracket d underscore v and we multiply by v, where q is a query, k is a key, and v is a value are the linear transformation of input encodings. Dk is a dimension of key vectors used in normalization. Essentially, self-attention mechanism enables the model recurrence and maintaining from the new raw in embeddings, similar to the diffusion models, denoise and step by step. There are some challenges and limitations of transformer architectures. There are some key drawbacks of transformer architecture. Highly computational cost. It means training large transformation requires huge GPU and TPU resources for the memory. Its costs lot more. The quadratic complexity. The self attention has a big O of n2 time complexity and memory cost is a slow for long sequences. Data hungry needs massive data set to achieve good performance. Difficult to interrupt, hard to understand what each attention hit to the learns. Example, processing very long text or documents become insufficient to the high memory uses attention overhead. Hey, here we comes to the summary part of transformer architectures. It is a powerful architecture for holding sequential data in machine learnings. They are self-attention to capture relationship between all tokens at once, enable parallel processing making them faster and more scalable than RNNs, widely used in GPT, BERT and vision transformations, VIT across NLP and vision tasks. Through computationally heavy new models are like difficult to transformers and long forms to reduce the cost, represent the fundamentals and functions of the modern generative and language of AI system. Transformers where attention become intelligence. It is the main line I can quote this transformation for this. Thank you very much. It's my part.